Hi, and welcome to the next lesson. In this lesson, we're going to cover mobile device connectivity. Let's look at our learning objectives for this lesson. We're going to discuss wireless and cellular data networks. From there, we're going to talk individually about the type of networks that we had experienced over the years on our cellular networks, the 2G, 3G, 4G, and 5G. Then we're going to talk about the GSM and CDMA networks individually and compare those. We're going to finish off talking about our preferred roaming list or PRL updates. That's how we get our updates on our mobile devices. And we're going to finish talking about hotspots. Okay, so let's go ahead and jump in today's conversation and get started. So the early cellular networks, the data network that your cell phone connects to, has gone through many changes throughout the years. In today's technology requirements, your mobile device connects to a robust network capable of streaming large amounts of data files like movies and videos, and able to connect to websites and a vast amount of information. Just think, not just your connection to this network, but everyone in your city or town. Or what about your state? Going further and beyond that, what about everyone in the country and across the world? This is a huge demand for connectivity. So, all those networks would have to be really, really robust. Now, let's take a look at how this network is constructed. From there, we'll look at how the cellular technology has changed throughout the years to accommodate our ever growing needs. At its smallest scale, the cellular network is a communication network where the connections to your device and other devices and the source from the source is all wireless. So this network is comprised of a base transceiver station or cell site, hence the name, cell tower, cell site, within an area where the antenna is communicating with the wired devices. Each cell would have a different frequency than its neighbors, so signals would not interfere with one another and provide guaranteed service quality within each cell. So if you can imagine all of these cells all across the area, geographical area, and they all have their own separate frequencies. And these cells together make up our entire cellular network. Now, the first generation or 1G cell phones, the service was an analog service and it was not designed to carry data at all. So at that time, we were thinking just voice, not data. In the early 1990s, two digital technologies emerged on the scene called the Global System for Mobile Communications, or GSM, and Code Division Multiple Access, or CDMA. GSM and CDMA were great for voice across the networks, but they were very limited as far as data. And as you've seen, our technology needs grow and grow. And eventually, we were at that time going to be needing data. So those networks were actually based off of circuit switched networks or circuit switched. Now, circuit switch, think of this of an analog telephone circuit where both parties have to be connected during the entire duration of the call. So that connection, that circuit was a connection, a single circuit connection where both parties are communicating and it does not end until one party breaks off. Now, if you could imagine that across the entire network, cellular network, that would be a lot of connections. So, of course, there had to be some type of technology to be introduced to make that faster and better. So that was very, very limited. Now, our newer networks are packet switch, which means data is broken up and sent in packets. This is very robust and can carry voice and data at the same time. We'll talk about that a little bit more later in the lesson. The original networks had to be upgraded to get to a certain level of packet switching just to get just a minimum amount of data sent across them. So let's talk a little bit more about the Global System for Mobile Communications, or GSM. The GSM network was an early starter on the carrier networks with approximately 90% of the cellular market worldwide. The GSM network was actually a European standard and provided worldwide coverage. So the European nations, they made that a standard, and that's what they wrote on. Now, the mobile device connects to the GSM network via hardware, a device or a piece of equipment called a subscriber identity module, or card. This is a SIM card that you and I probably come to know of. The SIM card provides the network with the identifying information about the mobile user. On the GSM network, a SIM card contains all the information about the device, such as the telephone number and all the other information. This information followed the SIM card. So a card could be moved to one device or another, and a telephone number would follow. GSM used a variation of time division multiple access or TDMA, which is kind of multiplexing, which is very, very efficient. This technology allows for many users to be on the system with shared time slots communicating at the same time. This system processed voice as well as data all at the same time in a certain area, and it was all orchestrated by the system. So as you can see, we've come a long ways from that circuit switch system where we're having multiple users communicate at the same time and also pushing out data. Code division multiple access or CDMA. Now, CDMA is another example of a multiple access system where several transmitters can send information simultaneously over a single communication channel. This allows several users to share a band of frequencies in order for the communication channels not to cause interference between the users. But CDMA was a little bit differently. It employed a sped spectrum technology and a special coding scheme. Now, this code is unique to the mobile device and the transmitter, thus having a private conversation. Your device could recognize other codes and see other codes on the network, but would only answer and communicate to the unique code issued to it. That was your phone call conversation. Your phone person on the other side that you were talking to had that unique code, and you had that unique code, of course, issued by the transmitter, and thus you had your private conversation. Now, CDMA was not adopted worldwide like GSM. In fact, the US was the biggest user of the CDMA network. The Verizon and Sprint were the largest carriers on the system. Okay, now we're up to 3G. 3G technology was first introduced in 1998 and networks deployed in the early 2000s. They had speeds up to 3 megabits, which was 30 times faster than 2G connections. And some of the 3G connections were up to 7 megabits. Now, 3G kept the features introduced in 2G like web browsing, streaming, SMS, and roaming, but it improved on the speed over connectivity overall and call quality. Also introduced during the 3G was mobile maps, GPS, video conferencing, multimedia streaming, and simultaneous voice and data calls. So 3G brought all of those new innovations and a new faster connectivity, and you can see that we're advancing in our technology. So from 3G, we went to 4G, which is the 4G LTE. Now, 4G LTE actually is a little bit more advanced. And actually, LTE, which was long term evolution or was a convergence of several technologies. Prior to 4G, we had both, of course, the GSM and the CDMA providers. This posed problems because some users wanted to use different networks or move between providers. LTE converged these standards. Providers that were either CDMA or GSM could now send voice and data over LTE. So LTE was a convergence of the two. LTE is based on the evolution of GSM, which was Edge, the enhanced data rates for GSM evolution. Um, Also, as a side note, CDMA did evolve as well, and they evolved to something called EVDO. Now, this new 4G or LTE technology improved throughput up to 150 megabits a second. Some areas saw LTE advance, which actually have throughput speeds up to 300 megabits. So we are moving down the improvement of technology when we have, again, 4G, the LTE. This improved a lot for communications, a lot faster in connectivity, and as well as call quality as well. So now we're up to 5G. And 5G was first deployed in the 2018 2019 timeframe. 5G works at higher frequencies that 4G and previous standards operated at. 5G is designed actually for speeds up to 20 gigabits based on the IM 2020 requirements. It's also designed to provide much more network capacity by expanding into new spectrums such as mmWave. 5G can also deliver much lower latency for more immediate responses and can provide an overall more uniform experience so that the data rates stay consistently high. Even when numbers are users, excuse me, are moved around, the experience that they are expected to have with the 5G is going to be quite overwhelming. So 5G is a game changer. And the new 5G in our mobile network is being backed by a Gigabit LTE Coverage Foundation, which can provide ubiquitous gigabit class connectivity. So there's a lot of excitement around 5G, especially in the business markets. You're going to be looking at increased speeds for businesses, lower latency, and also density of devices. That's expected to be around the capacity of 100 times more connected devices in a given area compared to 4G. So, what does that mean? The business can have more devices like IoT in a given area. Also, 5G and the new technology is lower power consumption. Uh, the devices that run off of 5G will be able to consume less power than the previous devices. And a last enhancement is would be security. The security hardware features and key management are going to be very much improved with the 5G systems. Okay, preferred roaming list or PRL updates. Updates or the preferred roaming list. This is how the CDMA networks, Verizon and Sprint updated their users' handsets. It allows your phone to connect to any tower, and this is where you get your OTA or over the air updates. And this gave more capability for markets as well. Hotspots. Before we wrap up, let's talk about hotspots. Now, with all this new connectivity and technology, our hotspots can be more robust than ever. Now, we talked about hotspots before on our mobile devices. So, with the new 5G capability and everything that brings, our hotspots actually through your mobile device could provide internet source for many devices in your given area. So your again device becomes an instant internet source shared by the devices close by you in your immediate area. Now, not all providers provide this service, of course, and you have to check for your data rates as well to make sure that there will be no additional charges. Okay, a lot of good information in this lesson. We talked about the wireless and cellular data networks. We went into detail and covered 2G, 3G, 4G, and 5G. We also discussed GSM versus CDMA networks. We hit on our preferred roaming list and talked about our PRL updates. And we finished off talking about our hotspots. I want to thank you very much for joining me with this lesson, and I will see you in the new lesson.